Perfect. Hi everyone, I'm Amaury. Okay, I'll talk in the microphone and I'll talk loud. So tonight my talk is about Light.js or how to build Dapps on top of a Light client. So first of all, before I start, raise your hand if you know what a Light client is. That's a lot. Raise your hand if you use the Light client. Very good. All right. So now I'm going to talk about Light.js, which is a JavaScript library on top of the Light client. First of all, who am I? My name is Amaury Martini. You can find me with this handle on the internet, on GitHub, on Twitter, on Reddit. I am a developer, a JS and a Dapp developer at Parity Technologies. I am the author of Light.js, which I'm going to talk about tonight. I also am the main contributor of Feather, which I will also mention tonight. And finally, currently I'm working on Polkadot.js, which is a JavaScript library on top of Substrate and Polkadot. So the talk tonight is going to be about Light.js. What am I going to talk about? First of all, why are we doing this? Why do we want to build Dapps on top of a Light client? What's the problem behind this? Second of all, how to use Light.js, how to start hacking with it. And third, what are the next steps at Parity Technologies concerning Light client, Light.js, and all the stuff we're doing in this direction. So let's start with the first point. Why are we doing this? Why are we building more Light clients? So the problem today is, as you all might already know, that running a full node is a major annoyance. As users, as developers, we would never run full nodes on our consumer laptops. So Infura some years ago came out with a brilliant idea to take care of all this annoying part and to run those full nodes themselves. And this was great. It helped the Dapp community to grow very fast. It helped Dapp developers to just write one line of code and they could connect directly to the Ethereum blockchain. So a big thank you to Infura. However, that was good at the beginning, and today we're starting to see some consequences. Here are some numbers that I found on the internet. So today, Infura serves that much requests. That's 10 billion requests per day. So it's all the mainnet plus testnet combined, but still a lot. And 35,000 dApps and developers are using Infura as their backend infrastructure. So these are huge numbers, and Infura is running at scale. And when you think about it, it kind of defeats the whole purpose of decentralization. So can we do better? Can we be a bit more decentralized when it comes to dApps? And so that's the solution we're trying to solve. And the answer we're using is a Light client. So most of you already know what a Light client is, but I'll still go fastly through the slide. So a Light client only stores headers. So it's light. It doesn't store any state. It doesn't store any block. Doesn't look at transactions, etc., etc. But by storing headers, then still remain trustless. The very interesting property of Light client is that it's really light. The sync time, instead of days, we have seconds. The state, Light client doesn't hold any state, so that's 0. And the total database size is around megabytes, or hundreds of megabytes maximum. So this means that it can run on really low resources, or even on mobile phones or other embedded device. And that's an interesting property. So now, how building Dapps on top of the Light client would solve that problem? So today we're on the left here, right? So we have this huge Ethereum network. So there should be lines. I think we don't see them much, but there should be lines. All the full nodes are connected to each other. So this is our Dapp, the little computer right here. It connects most of the Dapps that we've seen connect to Infura, to one of the full nodes controlled by Infura. And that's the only node the Dapp connects to. With a Light client, in the future, what we would like to see is that your Dapp actually has one Light client tightly coupled to it. By tightly coupled, I mean, for example, in a mobile application, your Dapp and your Light client will be in the same mobile application. So the Dapps makes JSON RPC requests. Instead to Infura, it will make it to the Light client. And the Light client will just look for peers on the Ethereum network. So it might find one peer here that belongs to Infura. That's not a problem. But it will also find another peer that doesn't belong to Infura. And there's also another one here that it can connect to. So if one day Infura decides to just shut down, this Dapp will still continue to survive. So that's the whole idea of building Dapps on top of Light clients. So this is the vision we have in the future, and we want to promote this vision. We want to motivate Dapp developers to use more and more Light clients as their backend infrastructure, and that's why we built this JavaScript library. Light.js, which will just it's a simple library that you can just install from Yarn and start hacking, and you know that your Dapp will work on top of Light.js. So how did it start, this Light.js? So at Parity we had this thing called Parity UI, which was like an app with a lot of Dapps inside. We've built around 15 or 20 Dapps. And by building all this Dapp, we came up with a lot of development patterns that we see constantly in our code, but it's also the community's code. So I'll show these patterns. I'll show 4 of the patterns. Let's say a simple example, I want a Dapp that constantly shows my latest ERC20 token balance, whatever token it is. So the first naive solution would be to poll the blockchain every 5 seconds, or every 1 second to say, okay, now give me the balance of that account. That works well, but it's quite naive. But it's still used today. For example, if you look at the MetaMask FAQ, there's one paragraph that says if you want to have the latest accounts controlled by MetaMask, you just poll every 500 milliseconds on it. So it's still used today, this pattern. Well, obviously there's some problems, like for example, you make a network request, and if the request takes 10 seconds to resolve, then there might be some race conditions. So it's not the best solution. There's some more smarter polling, like let's say I poll, I wait for the network response, and when I get the response, I poll another. I ask another time the blockchain to give me the answer of my balance. There are some other patterns that are more with a bit of more thoughts. Let's say so there's this thing called PubSub where you can listen to a certain channel and you get push notifications every time something happens. So it only works on some of the data on the Ethereum blockchain. So for example, it works on headers. You can listen to new headers and you say, okay, I'm pretty sure that between two blocks there's nothing happening. So I just listen to a new header, and every time there's a new header, I will poll the blockchain to get my balance. And also at Parity, we also have this special PubSub on states where we can just PubSub on any other JSON RPC. So that's also something we used internally in Parity UI that I mentioned before. So out of these patterns, some of them will work with Light clients, some of them won't work with Light clients. And if we select the Light client friendly ones, obviously this one will be the one that will make the most sense. The other ones are not it will work, but they're not optimized enough. PubSub on state will obviously not work on the Light clients. So for Light clients patterns, we're just taking this one in priority. And that's basically the whole idea of Light.js. We just look at all the patterns that are out there for Dapp development. We take the best ones, and we take the ones that are optimized for Light clients, and we put them into a high-level API. So, and the reason behind this is, so all these patterns are like, Ethereum Dapp Development 101, some knowledge that Dapp developers are supposed to know that they should follow, but it's not in a fixed API. So the purpose of Light.js is just to put this into a simple API so that they call a function, and behind the scenes, this library will choose the best pattern, will handle all the other stuff. So concretely, how does it differ when we develop Dapp? So this is a simple example with web3.js, which you might know. It's a JavaScript library to query the Ethereum, to talk with the Ethereum blockchain. We create a contract, we create a function that will update, that will make a call with Web3 to update the balance, and we just log the balance. And at the end, we just say, okay, I'm subscribing to the new heads, to new headers, and every time there's a new header, I will call that update balance function. So this works, and it works very well. But the thing is, the Dapp developer needs to know that, yeah, okay, this should be light client friendly. Yeah, I'm pretty sure this is not light client friendly, but he should know, and future developers should also know. And the idea with Light.js is you just import this make contract function from Parity.js, from Light.js, you create your contracts, you call one of the functions, and you subscribe to the results. And that's all the developer needs to know. Okay, and when he calls this function, he's absolutely sure that this will be light client friendly, so that if this Dapp is on top of a light client, it will work without any problems. So some characteristics of Light.js, it's very simple to use. Our aim was to make it as simple as possible. So right now, today, there's only 10 functions. You might think it's not a lot, but we built some pretty interesting stuff with only these 10 functions. These are basically the 10 functions that most Dapps use. To query the block number, to post the transaction, to interact with a contract. Light.js is reactive. So reactive programming is like a pattern or style of programming where you work with streams of data. Streams are like, if you imagine a line that represents time, you will have events that happens on the stream. Can be, your Twitter post on your Twitter feed, or you clicks on a button, but it also can be blocks on a blockchain. And that's why we feel like reactive programming is quite adequate for blockchain events. So every time there's something happening, you get a push notification. So it's a push mechanism library. The structure we're using in JavaScript behind is called observables. We're using a JavaScript library called Rx.js. You might know promises. Observables are known as promises on steroids. You can combine them, you can filter them, you can transform them, you can do plenty of stuff with observables. And there's a huge community behind observables. So that's the pattern that we're using within Light.js. And Light.js does a lot of dirty work behind the scenes. Basically, the idea of Light.js is that since we suppose that the provider of this API is going to be a light client, we want to make sure that the least resources are going to be used on this light client. So, for example, if we want to make a pub/sub on a new header, we will create, this pub/sub subscription, but we will also drop this pub/sub subscription when we won't need the subscription anymore. Let's say you go on your Dapp on a page where you actually don't need the header, then Light.js will automatically drop it. And if you come back to the first page where you need the header, Light.js will create that subscription again. It handles a lot of caching. If it finds that there's this data is already available, then you won't make another query. And this joins the last point. It only makes the least necessary network calls as possible, because there's latency involved. So that's something that we don't want to have a lot. So, and finally, at Parity, we use React for our UI, and so we built this Parity Light.js -React library that will integrate very well with Light.js. So below, you just have this component that will show the balance of blah, blah, blah is some number. And you add this something called decorator, or a higher order component. And this higher order component will just listen to this balance of and will put the value inside the component, and will update the component whenever the value of that balance changes, and only when it changes, not on every 5 seconds or on every new block. So Web3.js is obviously some kind of competitor to Light.js. Let me show you some of the difference we have between the two libraries. So first of all, the async management structure, primitive behind it. With Web3, you have promises, or something that they introduced recently called Promi events, which is not used any elsewhere in the community. For Light.js, we have only observables. It's battle tested, used by the JavaScript community. There's some kind of internal war between those two. So we decided to go with observables. Web3.js, is it light client friendly? Yes, it can be, but again, it's the Dapp devs' responsibility to make it light client friendly. With Light.js, you're sure that it's going to be always light client friendly. And the JSON RPC coverage, so Web3.js has 100% of the JSON RPCs. Light.js doesn't want to have 100%. It focuses on simple APIs. So we have right now 10 functions. We will add more if we need or if the community needs it. But we're just building from as simple as possible. So can I use it today? Can you download and use Light.js today? The answer is yes, but we don't actually recommend to use Light clients today for production dApps. We still believe that it's not mature enough, that there's some other challenges that we'll talk about after that are not solved yet today. So if you create a dApp on top of a Light client, maybe on alpha or beta version, but don't put it to production-wise. But we do recommend Light.js for every kind of dApp, actually, even though you still use Infura as a backend, because, after experimenting with Light.js, we found out that it works very well with remote backends like Infura. There's the similar, network latencies problems that we need to solve, and in particular, it works well with MetaMask. So if you want to try today, just download it, create a dApp. Plug it in, and you can interact with the Ethereum network via Light.js. And the good thing is, if our vision of embedding Light.js everywhere works, then if you want to switch to a Light client, when they become more stable, then you won't have to change a single line of code in your code base. That's some experience that we went through when we had this old Parity UI. We tried to run it on top of a Light client. Half of the dApps didn't work because we didn't have that library. With this Light.js, we will be sure that it will work. So if you want to get started with Light.js, go to this website, this URL. It's like a documentation page where you have tutorials. How to get started, some guides and some concepts of Light.js, and the full API, so everything is documented. Everything is in TypeScript, you have types. There's a lot of examples, etc., etc. And of course, the code is open, so we cannot see here, but there's a GitHub link over there. The code is open source under the MIT license, so you can use it from today. Next step, we have Light client. So that was Light.js, but we want to do more stuff on top of Light clients. Our goal, like I said, was to embed Light clients everywhere, which we believe actually will facilitate the Ethereum mass adoption, particularly in mobile phones, etc., while maintaining the centralization. But of course, it comes with challenges. So the scope of the talk today is not to talk about these challenges, but I need to mention because it's quite important. The biggest challenge is how to incentivize full nodes to serve Light clients, because right now, Light clients are only leeching on the network. They're not in any way helping the network. So they are asking for free data on the network and they're receiving them. So we need some incentivization layer on top of Light clients, to control that. At Parity, we started something called the Parity Light protocol, which is based on a credit system where Light clients will have credits, and if they ask for some requests, their credits will drop and will slowly fill up with time. With this way, we can control a bit the Light clients don't spam the full nodes. There are other teams like dnode, VIP node working also on full nodes incentivizations. So this is a big problem that needs to be solved before Light clients become mainstream. On the side, we will, of course, also promote people to start thinking about building dApps on top of Light clients. So to improve Light.js, in particular, we want to add more functions. We want to add some prioritization of network calls because some of them are more expensive, like they use more credits typically than other calls. So we want to prioritize inside of Light.js to warn the developer somehow that, okay, maybe this call should be made before the other one, etc. Want to make it more configurable so that the developer can choose which calls he finds are more important than others, so that there's some hierarchy of functions to use, etc., etc. And to show you the power of Light.js, we built actually a full Ethereum and ERC20 token wallets on top of Light.js and on top of the Light client. And it works very well. So it uses Light.js, it's bundled with Parity Ethereum, which will be run with the --Light, so only the Light client will run. It syncs in 45 seconds, so that's really cool. It's a desktop application. It has only 3 screens, so a very simple UX. And the alpha version will be released next week. We still have some rough edges to fix, and we wanted to for the Devcon to not in the Devcon craze, but to wait a bit. So next week, if you follow the blog, if you follow Parity's Twitter account, you will see that this Feather application will be released next week. But today, if you want, you just go on this GitHub, parity.tech/feather, and you can download the binary, you can see the source code, you can build it yourself. So basically, we cannot see much here, huh? So it's just 3 screens. First screen, the list of accounts that you manage in your wallet. Second screen, for each account, the tokens and your Ethereum balance. You can add a whitelist of tokens over here. And third screen is to send Ethereum or send Ether or send any tokens. So super simple UX. We didn't want to do anything complicated. We're actually not that good at UX at Parity, so it's not we just want to build a proof of concept. But the most important thing is it's working. Light.js is being used. You can build dApps today with Light.js, but as I said, it's not production ready, so we're releasing as an alpha, and we're only releasing on the Coven testnet. And we have in the future to embed Feather a bit everywhere. First of all, our next target would be Android. We already managed to run Parity Ethereum Light client inside an Android app to make a JSON RPC request and to receive the response in the Android app. So that's that's 90% of the work done on the Light client. We don't unfortunately have enough resources to work on it, so it's not being actively maintained. In the further future, we want to have Feather as a browser extension, ideally. Something like MetaMask, but instead of MetaMask connecting to a backend, we would compile Parity Ethereum, the Light client, to WASM so that it can run inside your browser with almost native performance. And this Chrome extension will just connect to that Light client inside your browser, and your browser will be a Light node in the network. And in the long term is to have Feather as a website. That will be the holy grail. To just type feather.parity.io will sync in 45 seconds or hopefully less, 10-15 seconds, and you can have this website as the website is a Light node in the network. So if you're also interested to add the Light client inside your project, come talk to us, because we would be very happy to work with you on that. Thank you very much. You can find me, Amaury Martini, this. You can also have a look at the documentation. So thank you for listening to my talk.
Do we actually have time for questions? We think so? Well, let's do 1 or 2 questions. Does anyone have a question? Give you a second. Anyone have a question? Oh, what's your question?
Basically, how much wallets is going to support the Parity Light client in the future?
So the question is how many wallets are going to support the Parity Light client in the future? Currently none of the wallets are supporting, but we are actually working with some of the most popular wallets for them to at least try the Light client as as one of the potential providers to have. So I won't say any names, but there are some wallets interested in having a Light client as a possible provider.
Do you have? You didn't have a question? Do you have a question? All right. Maybe you could also just shout it out. I think he'll just repeat it.
Am I correct to assume it requires WebSocket connections? If so, Infura doesn't support you.
So Infura does support since. Oh yeah. Oh yeah. Not for Kovan. Okay. No, all right. So I'll repeat the question. So the question is like if we do some PubSub, we obviously need a WebSocket connection for the subscription. However, Infura doesn't support PubSub for Kovan. So yeah, how do we solve that? So okay. So the answer is. Right now on Kovan, right? So the answer is like in Light client, there's some intelligent thing that says if PubSub is supported, then I will use PubSub. If it's not supported, then I will just query every I think 1 second. Right now it's configured. Yeah, so that's the I mentioned like we want to make it more configurable. That's part of the making more configurable. Right now it's hard coded, but shouldn't be that hard to add some config somewhere.
Also, there will be a break, and maybe you can talk to Amaury more if you want to. Okay, thanks a lot for the talk.